Hey guys, we are at part 2 of day 8. This is page 3, and hopefully if everything has gone according to plan, part 1 should have been recorded live, is what I'm hoping. Part 1 I'm hoping was live, which means it should be up by now. I should have already recorded it and had the Edpuzzle up and going, but just in case, the video for that may come up a little bit later if something went wrong, but we're going to assume everything went right. And so, as we're on part 2 here on page 3, I'm going to let you guys, just like we've been talking about, take what we're given, QO bisects MPQ, and QN bisects MQO. And let's break that down. So QO bisects these two pieces, and QN bisects MQO. So check that out. So we know that this piece, this ray, bisects this angle, and this ray bisects this angle. And so with that in mind, guys, again, on this page, we should be able to do most of this on our own. We should honestly be able to handle most of this on our own, guys. We've seen it for 5 days now. We've worked with it. So whenever you see, oh shoot, 1/2, and we're talking about bisecting, your first thought should hopefully be the angle bisector theorem. And so I'm going to let you guys finish 3 and 4, and then I'm really going to trust you on this one. This is big. This is going to be a big moment for us. I want you to try the whole. Try the whole problem from 1 through 8. And we'll see what you guys got. Let's see how you guys did. So, remember that if we know that angle 4 is really 1/2 of the whole, we can then say that angle 4 is going to be equal to angle 5. We can say they are congruent pieces based off the definition of a bisector. Because 1/2 of MQO, well, 1/2 of that is going to be the same thing as angle 5 based off the definition. And if you don't remember, bada boom, definition of an angle bisector, then it divides an angle into 2 congruent equal parts. 4 and 5, 2 congruent equal parts. We see that right there. And so then, what's going to let us make this final statement? Well, wait a minute. We've said angle 4 is equal to 1/2 MQO. Angle 4 is also equal to angle 5. Let's cut out the middleman. And what can we really say here? Angle 5 is really just congruent to MQO based off the transitive property. Nice. And then down here, we're going to go rapid fire, guys. We've got this. Big things. A and B, we're told, are supplementary angles. We're given that. Also, angle A is 4 times angle B plus 7. So angle A is much, much bigger than angle B. But you're going to see something pretty familiar here. Talking about supplementary angles, and that leads right into those 2 angles then are going to add up to be 180. Words lead to math. That is the definition of sup. The definition of supplementary angles. Well then, wait a minute. Why did A become 4 times B plus 7? Oh, because we know that we can substitute. Using substitution, we can plug that in for angle A. And from here, guys, this just becomes an algebra problem. The rest of the way, this is all algebra. So check it. We've got 4 angle B's plus 7 plus 1 angle B, like terms. We can combine them. Little CLT action. Then if we're trying to solve for angle B here, you want to subtract 7 over. So we subtracted 7, which is what led us to that. Then we divide by 5. And so we find out that angle B is really 34.6. Well, then how can we find out what angle A is? Well, isn't angle B used up here? Check it out. Angle B is really just what angle A is, except we multiply it by 4 and add 7. So when you do that, you end up with 145.5 thanks to substitution. And wait a minute. We're going from A to A here. This is math. This is words. Look back to obtuse angle. We got math followed by words. Let's look back at an obtuse angle and make sure we get this right. So the definition of an obtuse angle is if an angle is obtuse, then that angle must be greater than 90 degrees. Wait a minute. We proved that it was greater than 90 degrees first, and then stated it was an obtuse angle. That's not right. Ooh, but what about the converse? If an angle's measure is greater than 90 degrees, if math comes first, then that angle is an obtuse angle. That's what we have here. If the angle is bigger than 90, then it's an obtuse angle. So this isn't the definition of obtuse. This is the converse of the definition of obtuse angles. Hey, let's go. All right, we may be on the last page with just 2 problems, but this could be a little tough if you're not ready to be able to handle statements and reasons. If we were given the statements for these, I think you guys would find these pretty easy. But this is where the challenge comes in. And again, what I like to do is I like to see what the topic is. Because whenever we discover what the topic is, it can help us with our statements and with our reasons. Well, let's see. Angle ABD is equal to angle CBE. Here's ABD. And we're told that's really equal to CBE. CBE. So this one right here. So in other words, we're told, that this angle and this angle are congruent. Well, then naturally, it may make sense if this angle and this angle both share 5. It would make sense then if these are congruent that 4 and 6 would also be equal. And so that's what we're going to try and prove. And so let's give it a shot here, guys. So step 1, we're told the measure of angle ABD is equal to the measure of angle CBE. And that's straight up given to us. Well, here comes the tough part. What do we do for step 2? Well, that's where you really need to understand what kind of problem you have. So this is really, if it's an angle and an angle, and we're saying we've got parts, what's the first thing that we think of for our topic? I'm thinking part plus part equals whole. That's exactly what I'm thinking. And if you notice, we have 2 of these here. We can say that, let's start with ABD. We can say, what are the angles that make ABD? ABD, 4 and 5. We can say that angle 4 plus angle 5 equals the whole, the measure of ABD. And how can we say that? That's some good old-fashioned angle, add, post. We can do the same thing for 5 and 6 here. Check it out. Angle 5 plus angle 6 is going to be equal to measure of angle CBE. Same exact principle, guys. Angle, addition, postulate. And so if you can believe it, we're to the last step here. And why are we to the last step? Well, because look at what we've established. If angle 4 plus angle 5 is ABD, if angle 5 plus angle 6 is CBE, and we know ABD and CBE are equal to each other, cut out the repetition. See, boom, 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 boom. We know those are all equal. And we know that angle 5 plus angle 4 is that, and angle 5 plus angle 6 is the same thing. Cut that out. What are you left with? The measure of angle 4 is going to be equal to the measure of angle 6. And what property can we think for that? Well, that's the transitive property. Nice. And then the last one, guys. Now, I'm going to let you get started on this one. Again, in pencil. And look at what they gave us. We know that these are going to add up to be 180. That's going to be something we can start on. And big thing is we're told that angle C is going to be equal to angle D. So we know our topic, we're talking supplementary. And what are we trying to prove? That these are perpendicular. Those are our two topics, guys. We're trying to say that this angle and this angle add up to 180. And because of that, we can prove they are perpendicular. So I'm going to give you guys a chance to try this out. Okay, the moment of truth. Let's see how well you guys did. I'll give you a hint. There are 7 steps. 7 total. So if you're close to that, I'm liking your chances. So we're given that C and D are supplementary, and angle C is equal to angle D. Well, then you guys should be thinking, okay, if we're talking about supplementary, we know that that means that these are also going to add up to be 180 based off the definition of the supplementary principle, property. So, and again, we can say that because we have words that lead to math. Well, then, think about it, guys. If angle C plus angle D equals 180, and we know that angle C is really equal to angle D, couldn't we replace angle D here? Let's replace angle D with angle C. And how are we able to do that? Some good old-fashioned substitution. So if we know this, then we can plug that in right there. And then from here, guys, you get into an algebra section. Check it out. This is all algebra. So once you substitute, you do C plus C. That's 2C, combining like terms. Then we divide by 2. When you divide by 2, you find out that angle C is really 90 degrees. And wait a minute. If we're talking about perpendicular, we know we need to establish that we have some right angles, right? Perpendicular needs right angles. So then if C is 90 degrees, that means C is a right angle. But wait, we have math, then words to prove that. If that's the case, converse of the definition of a right angle. And then, again, we know how we need to end. If we have proven that C is a right angle, we know it also means D is a right angle. And so we can say CA is going to be perpendicular to CB based off here's the thing, based off the converse of the definition of perpendicular lines. Because take a look, guys. If two lines, rays, segments, or planes are perpendicular, then they form right angles. Well, that's the regular definition. But that's not what we have here. We have a right angle, therefore we have perpendicular. You see the difference? Converse. If right angles are formed, then the two lines are perpendicular. Right angle is formed, two lines are perpendicular. Converse of the definition. Whew, great job, guys. If you have any questions, please contact me. I'd love to help you in any way. Take care.